103. According to food labeling laws, a certain fast food cheeseburger has 750 calories. We suspect the actual calorie count is higher. We plan to randomly purchase 36 of these cheeseburgers. All right, so friends, this problem is very similar to one of the problems on the quiz we will have on Wednesday. Cool? So definitely write this one down, okay? Shh. Definitely write this one down. All right, so we have a null hypothesis and we have an alternative. So we think that they're higher. We're going to say that hamburgers are equal to 750 calories. We're claiming that it's higher, greater than. Okay, so there's our null and our alternative. Okay, so calculate the mean. The mean is 750. And the standard error, aka standard deviation, is going to be where did we see it though? You know what I think they forgot to put in here?
What the alternative people thought?
No, they didn't. So they should have. So this was missing from it. The actual standard deviation was 100. Okay, that was missing from there. Hey, how are you, sir?
Good.
Doing well. So make sure you add that. We forgot to put the standard deviation in there of the burgers. So we feel it's higher. So we want to find the standard error. So the standard error is going to be the standard deviation. The standard deviation that's given. Yeah, I can't believe we didn't have that. Hey, how you doing?
He said, what? He said, ooh, I like this one.
That was the first time I see you figure out how they're going.
So Jensen's came in, page 103 is around. This first problem is very similar to what we're doing on the test. You need to add this. They forgot to say that, but I have it worked out with it in there. So the standard error is going to be 100 divided by the square root of my sample size. My sample size is 36. So that means my standard error comes to about 17. I mean, it's 16.67. So we'll just say it's about 17.
Wait, how did you get the square root of 36? Where did that come from?
The standard error in this standard error equation is the standard deviation, which I had to give you because we didn't give it to you, divided by the square root of the sample.
And will each one on the test be, will the same deviation be on all of them?
Yes, I will put that there. We had forgotten to put it in there. All right. So about 17. So then if we want to create our normal curve on this, our normal curve kind of looks like this. So in the middle, we have the 750. And then we're going to go 17 above that. So 1767, 1784 or 784. And one. Oh, it just goofed up.
I was having a good day.
My thing just crashed on me. Let's go a little back up. I thought we were doing so good. We were good friends today, and no, it goofed up on me. There we go. Uh-oh, this thing really slowed down on me.
That's what we bad.
All right. So number one, we know that H naught is hamburger equals 750. H alternative is hamburger is greater than 750. We found the mean of 750. The standard error we found is about 17. And then number three, our normal distribution should look like this. 750, 767, 784, and 801. And then this way subtract it, 733, 716, and 699. Okay, so everyone feels good so far about this, right? All right, so then we get to number 4. And number 4 says, assuming our random sample produces an average of 747. Produces an average of 747. Is this strong evidence? Well, here's where 747 falls.
That's easy.
Okay, this is where the 747. So, is this strong evidence against our null? Well, no. It's one, we want to know, are we greater than 750? Well, I'm at 747. So, clearly our sample is not there. It's very close to the 750. This could have been just random chance that this took place. We think that they should be greater than 750, but we found a new sample we did was 747, which is truly below that, so it's even the wrong direction. So that's what's taking place. All right. So now let's use our Desmos, my favorite. All right, so we're going to go normal distribution. And of course, we have it based on using the calculator. I'm going to use this so we know that we are at, our mean is 750. Our standard error is about 17. And we said, and then what's the chance? Okay, using the normal distribution, that's to the left. So I have negative infinity here, and then I have 747 here. So this comes out to roughly 43%. Okay, so guys, that 43%, if I move the decimal over twice to make it a decimal or a percent, that's technically our p-value. Okay?
Wait, say that again. What's the p-value?
So this is technically our p-value here now. Okay? All right. So that's number 5. Okay, assume that our random sample produces a calorie count of 771. Is this strong evidence in favor of our alternative?
Yeah, because it's greater than 750.
Yeah. Actually, if we plug this in as 771, I mean, all of a sudden, we're jumping up to like 89%. Okay, so this is better. It's still fairly close to 750. I mean, it's 21 away. It could be mere chance. Okay, but like how far could we get away? And what really takes place is when we start looking at that 0.05 thing. And then explain what a type 2 error would mean in the context of this question. We failed to find strong evidence that these cheeseburgers average more than 750, but they really do average more than 750. So that's kind of the type 2 error. So we failed to find strong evidence that cheeseburgers average 750, but they really do. All right. Now, this backside is going to be very similar to the other word problem. Okay, you with me on page 104? Okay, so let's go to this. All right. So they tell us recent government reports 27% of the United States population has no health insurance. We believe the percent might be lower. We want a random sample of 1,000 people to use. Okay, null and alternative. So our null and our alternative, we feel that P is 0.27, and then we feel that P is less than 0.27. And the reason why this is no longer a not, it actually is a not based on what we feel our conclusion would be. We believe that it's less than 27% have health insurance. So the not of our alternative is that equal. Okay? Calculate the mean. So number 9, our mean is 0.27. And then our standard error. Okay, note this, please. This standard error is going to be a little different. This is the P, 1 minus P, divided by N, all under the square root. So this is going to be we have 0.27, we have 0.73, because 1 minus 0.27 is 0.73, divided by the 1,000 people. So this is coming out to 0.014. Which is basically 1.4%. Okay? We can create our normal curve based on this. Our normal curve is going to look like this. So this is 27%. And then add 1.4 to each. So I go 28.4 here. We go 29.8. And we go 31.2. These are all percents. Subtract. So 0.256 or 25.6. 24.2. And 22.8. Okay. So are we good so far on this question? Everyone feel comfortable with what we resolved? All right. Which would be a result? Which result would produce stronger evidence? Okay, would a 22%, which is here, or would a 24%? Which one is the stronger evidence? And you have to look at the 22%. It's farther from the 27%. So this is further, the 22% is further from our 27%. Explain why a random sample that shows 36% have no insurance. So 36% is like way over here. Okay, so first off, this 36% is in the opposite direction of what we're looking to test. We think it's lower than 27%. We found 36% in some sample. So that's kind of a, like, dude, what happened? Did we not collect the right data? Says the results the opposite direction. It provides evidence that the percent with no health insurance is greater than 27%, not less. So it kind of goes against what we had directionally said in this one-tailed test. And then if we ultimately decided to reject the null hypothesis in our study, what would it mean? We would find strong evidence that the percent without health insurance is below 27%. Okay? If we decided to reject the null, that our null is equal to 0.27, explain what it means. That it just means that we found strong evidence that it's less than the 27% that would have the health insurance. So those two problems, then they're recorded, will be very similar to the 2-word problems that you will see on the quiz on Wednesday. Okay, does that make sense?
How many questions are on the quiz on Wednesday?
It's a front, back, front. So however many that is. 3 questions. Well, it's
No, 3 pages.
3 pages, but it's not that long. First page is all multiple choice. The second page is like number 7 that we just did, and what we did right here, 1 through 7. And then the second question on the 3rd page is very similar to this one. All right. So let's hit up on 6.7. All right. All right. So I'm going to sneeze. I feel blessed. It's not coming yet. It's thinking about it. So I'm going to be on page 36. It says, calculating the p-value in one-tailed test. Well, we already showed how to calculate the p-value. It's the normal distribution with the mean and the standard error. And then you either have something going from negative infinity to a value or from a value to infinity. Okay? So the probability of obtaining a result at least as unlikely as we would have obtained by random chance. Okay. So halfway down, they said the average price for a movie ticket is known to be $11 in the year 2010. Has the average price of a ticket for a movie risen since then? Assume our plan, survey 600 people. So our null they give is our movie tickets are $11. Our alternative is movie tickets are more than $11. Okay, draw a sampling distribution. You know what we forgot to give you in this one too? Hang on, let me look at one thing real quick. Yeah. You know what they didn't give you in this example? They didn't give the standard deviation again. All right, so on page 36, let's call the movie ticket $11. And let's say our standard deviation is 50 cents. Okay? They didn't give us that again. Okay? So again, I'm adding this to our problem. Okay? They didn't give it. I'm sorry, we're losing our minds on this chapter. All right, so my mean is the 11. My standard error is going to be our 0.50 divided by our square root of 600. So we're going to come up with 0.02 on this. So standard error comes out to roughly 0.02. All right. So draw our sampling distribution. This goes in that blank. So we have 11, 1102, 1104. And I totally smashed this because it's 1058 or 1098, 1096. And 1094. Again, I had to come up with a standard deviation. We didn't have one, so we just went with that. All right. So let's assume our produced. Let's say we came out to $11.45. So $11.45 is way over here. Okay. So is that $11.45 close to $11 as far as our standard error, or is it far away? What do you guys think? Is that $11.45 that's there on the far right? Is that close to our $11 or is it way far away? It's way far away. Okay. So let's figure out. I actually know what our p-value is. Our p-value, if we do this, we have 11, 0.02, and we're going to call this. Do that. We're going to call this 1145. So look how far away my 1145 is. I get to an answer of 1. I mean, it's 100% of our area under the curve. I mean, we got to round it. I think we can actually tap here and it'll give us. Nope, I was just thinking it might even give us a value. So we are so far away from it. So in this case, our p-value in this is like 1. Okay? So let's say they chose to have an alpha of 0.05. What would the decision be? Okay. This would be we reject the null. We found our, let's see. You want to say we reject the null? We failed to reject let's see. We are going to reject our null hypothesis because we found strong evidence to support our alternative. Okay, so we are way far out. Okay, that p-value of 0.05 means that we have a 5%, or the alpha of 5%, 0.05 means we have a 5% chance of making a type 1 error. Okay, so that is what I got for you. So let's have you guys work on page 105, 106. And we should be good. Perfect. I just